Thank you for thank you for introducing me. Hello everyone. I'm Keita Nishimoto from NTT Japan, and I'm also working in ONF, mainly for SEBA project. I'm here to talk about our proposal, Mini-PON. That is an architecture for the future optical access network. Oh, sorry, I forgot to bring this kind of things. I'm afraid you might be a little confused when you check today's schedule, because it only explains this presentation just as Mini-PON. I'm afraid you might think, what is it? To be honest, I'm also surprised to see that title is also minimized. And however, I feel that was not so bad, because this simply represents what I want to talk here. To save the space. So I mean, that I guess this is because our title is too long, so it was shortened for saving the space in the website. So this simply represents what I want to talk here. To save the space, that is one of the goals which we aim with Mini-PON. And the other goal is to enhance the flexibility of optical access network in the future. We use module-type pluggable OLT and softwareized OLT functions for these purposes. Please keep in your mind these goals to enhance the flexibility and to save the space for deployment. There are the goals of our proposal. Please take a look at this, the top of this slide. As you know, the OLT device is composed of some functional components. It includes DBA, that is an abbreviation of dynamic bandwidth allocation, that plays an important role to control the QoS of upstream traffic of subscribers, and OAM function and multicast function. We will decouple these functions from hardware device and will implement these functions as software running on a commodity hardware and commodity server. That is what we call softwareization. The softwareization makes these functions flexible with the service change, because we can update and modify these functions very easily, because they are running on a commodity operation system and commodity server. It also enables us to minimize the physical size of pluggable type OLT module. Please look at that image. That is a prototype which NTT made using FPGA chip as a module type pluggable OLT. We believe this kind of module type OLTs lead to cost reduction for device OLT. You can plug this module type OLT to the commodity hardware like SFP module. This makes the deployment task very easier, and it doesn't require a large space for deployment. That is the point of our proposal. We believe these features will diverse the applications of passive optical network in the future. So far, the main target of PON system are FTTH, fiber to the home, or fiber to the office. However, in the future, it will reach to the factory local area network and company LAN and other fields. Let me show you the specific application of Mini-PON. Please imagine the factory where there are many robots and sensors and their controllers inside. We believe in such an environment, passive optical network, and especially Mini-PON, is a very promising way to build a local area network inside the factory to connect these devices. Because passive optical network is not disturbed by the electric noises in the factory, and it can accommodate a number of devices per port. Especially Mini-PON doesn't require a large space for deployment, right? You might be concerned whether the passive optical network can require the low latency requirement because for factory LAN, because the requirement is so different from the one for other services, such as requirement for fiber to the home or requirement for company LAN. It's no problem in Mini-PON, because you can change the dynamic bandwidth allocation algorithm in Mini-PON very easily. Let's say you can use the dynamic bandwidth allocation algorithm specialized for low latency when you want to deploy the Mini-PON in the factory. On the other hand, you can use the bandwidth allocation algorithm specialized for bandwidth utilization if you want to deploy this system in the company LAN. I gave an example of DBA algorithm for showing the flexibility of the Mini-PON, but you can also add other functions to this system if you want, such as security service function or power saving function, and so on. Next, move on the introduction of the demonstration which we are making now. We implemented Mini-PON based on SEBA design, which ONF community regulated. We show the feasibility of Mini-PON, and SEBA can support the various kinds of use cases, including ours. In specific, we will show the SDN controller, that is ONOS, can manage a pluggable module type ORT, and we can switch the softwareized DBA function. We can switch the softwareized DBA function from the voter. Let me introduce the overall architecture of demo system which we made. As I mentioned earlier, this architecture is based on SEBA design. In specific, we use ONOS as a SDN controller and Voter 1.5 as a driver for controlling these devices, or the computer server, hardware module, and ASG that connects these devices. ORT computer server is a commodity server which you can purchase in the market. And in that server, we prepared softwareized EPON OAM and two types of DBA functions running on the server. The hardware module connects with the device via ASG. ASG connects these devices. By the way, we are now promoting the standardization of interface between the hardware module and the server. Exactly speaking, not server. Interface between the hardware module and the softwareized DBA function. I will talk about that interface information later in this presentation. This figure shows the management architecture of this demonstration. ONOS manages the data path, user data path in the hardware module and the control path in ASG. On the other hand, Voter manages the activation of module and activation of software function. In detail, we use NTT adapter and module manager running in the ORT compute. Module manager activates hardware module and software's DBA after receiving gRPC message. Let me show you a part of demonstration which we are making at the expo room, next to this room. The right-hand screen represents the flow entries that exist in the ORT module, and the left side screen represents the throughput of packets that gets through the module. Oops, sorry. Give me seconds. You can see the throughput, so the y-axis of the left-hand screen represents the throughput of packets that gets through the module, and it becomes 0 when the flow entries was removed. And after putting the flow entries again, that throughput was recovered. This proves that the hardware module can be controlled and managed by ONF successfully. We released the workflow for Mini-PON in the wiki page of SEBA design. I believe this information is valuable for other carriers who are thinking of deployment of pluggable module type OLT as well. We hope to discuss the workflow with you. Let's say how I can integrate this kind of workflows to the other workflow for example, for box type OLT that is commonly used. Let me touch on the FASA project for explaining the grand design we have. FASA project is an abbreviation of Flexible Access System Architecture. NTT has been promoting this project in this couple of years. The basic concept of FASA is very similar to the SEBA architecture, because it aims to modularize the function of access network equipments for providing various services without hardware modification. The basic concept is mostly same with the SEBA. Mini-PON concept, which I talked here, is a part of FASA project. I personally think the difference between the FASA project and SEBA project is that the FASA project focuses on the modularization of functions inside the OLT device. As I mentioned about the DBA function modularization at the beginning of this presentation, the modularization, the target includes the functions inside OLT device. Especially, we focus on the interface, standardization of interface between hardware and software, like that. We aim at running the same application and same softwareized function on different types of OLT, different type of hardware, such as running on same DBA function, both of box type OLT and module type OLT. We actually made a demonstration in BBF conference that took place in this June. This demonstration is very similar to the one which we are now doing here. In ONF Connect demo, we assumed the switch of DBA that assumes the factory RAM. On the other hand, this demonstration that we did in BBF assumes the concept of the PON use case for mobile front haul. For using passive optical network as mobile front haul to connect the mobile station and control unit, the low latency DBA is needed. The box type OLT has an interface that the FTTH DBA and mobile front DBA, both of them can use. So we can easily switch these different types of DBA without hardware modification. That is the point of BBF demonstration. We believe this kind of flexibility of service flexibility and hardware selection flexibility will diversify the applications of a passive optical network in the future. Okay, let me explain the contributions which NTT Labo has been promoting. NTT Labo has been contributing to SEBA project in both aspects of development of software components and R&D draft making. I want to say thank you for ONF communities for supporting me so far. Especially for the development of SEBA, I have been developing the BBSIM. BBSIM is a software emulator that is for scalability tests of VOTA and ONOS. That emulates the multiple ORT devices and ONU devices. This image shows that the BBSIM successfully emulates the one ORT with 16 ONUs. Now, the BBSIM only supports the unique BBSIM ORT adapter, but we are now trying to make this BBSIM supports the open ORT adapter. The source code of BBSIM is now on the GitHub, so if you have an interest about this, please give it a try. NTT AS Lab will keep to contributing the SEBA project because we have a plan to develop the operation system of Mini-PON that we propose here by the end of the next autumn using VOTA and ONOS. Especially, we focus on the functional expansion of VOTA to create the functions such as EPON support and ONU test function that are not supported by the latest version of VOTA. Let me wrap up my presentation today. We implemented Mini-PON based on SEBA design. I believe that can show the feasibility of Mini-PON, our proposal, and SEBA can, support the various kinds of use cases. We will keep contributing to SEBA project from now on, and I'd be glad if you give me some comments or questions or use cases that are related to the softwareized ORT function and pluggable type ORT module. Thank you for listening.
Anybody has a question? I have a question. So the last thing you talked about was BBSIM, and you mentioned BBSIM working with OpenOLT adapter. Are there other things on the BBSIM roadmap that you want to work on?
I see. So, as I mentioned, one technical problem which BBSIM is now have is OpenOLT support, OpenOLT adapter support. But we are now thinking of the increase of the ONUs that the BBSIM can emulate. So, I mean, as this picture shows, the BBSIM is now, the limitation of the numbers of ONUs that now current BBSIM can emulate is just 16 ONUs or 32 ONUs. However, I have to, increase the number of emulated ONUs for scalability tests of VOTA and ONOS. So I'm not sure why this cannot emulate more than 16 ONUs. That may be because of the VOTA performance or BBSIM performance. I'm not sure, but I have to investigate how I can increase the number of emulated ONUs for scalability tests of VOTA. Does that answer your question?
Yeah, thank you.
For VOTA 2.0, do we have to make any changes to BBSIM? I would not.
For 2.0, right? I will. So, to be honest, however, I think the main topic of VOTA 2.0 is the containerization of OpenOLT adapter. So, I have to, discuss about that with community, whether we can, put BBSIM into the 2.0. Does it make sense?
So if OpenOLT adapter works on 2.0, then BBSIM can work with OpenOLT.
I see.
Otherwise, you have no dependency on the 2.0.
I see. Yes. You're correct. You're correct.
Curious if you could speak a little bit more about the choice to put the DBA for the PON outside of the module.
Yeah.
And what the costs and benefits of that was in terms of latency or flexibility.
That's a good question about the technical problem when we separate the DBA from the hardware, right? So as you say. As you pointed out, the distance between the hardware module and the server becomes longer. The polling interval becomes problem. So I mean, if there is a big latency between the hardware module and the server, the polling cycle becomes longer, and it makes the upstream latency against the upstream packets of the subscribers. I guess that is one problem which this kind of architecture has. Does this answer your question?
It's what I was getting at, but I was curious what you must have known that in advance.
Mm-hmm.
You chose to do that. So what's the advantage of that?
I see. So, I understand your question is about the merits and the demerits, disadvantage of this proposal. So the merit is as I mentioned earlier, the flexibility and easiness of modification and update of this kind of functions. And disadvantage is the unstability of the function. So this software is running on CPU, so it's sometimes, the processing time sometimes fluctuates because of the interruption of processing. So it may be one of the technical issues this architecture has. Does anyone have a question?
Other questions?
What kind of NNI interface you have on ONT compute server?
NNI? Sorry, I didn't understand what the NNI meaning.
ONT compute server to aggregated switch.
Oh, sorry. That is because of my shortage of explanation. So okay, give me a second. The packet date is getting through the ONU and module and aggregation service gateway. So NNI is here, not here. So this compute server is only for controlling, controlled functions such as DBA functions or OM function. So the data packet doesn't enter to this computer server. Does it make sense? Does this answer your question in the right way? Okay.
Any other questions? All right. Thanks, Keita.
Yeah, thank you.